Hasnat Khan, can you add the registration number, otherwise NIC number, into your name? Hasnat Khan.
Yes, sir, I do.
Yeah. Lovesia. Lovesia. Can you add your number into the name? Chanuka Pereira. Chanuka Pereira. Randhir Chanuka Pereira. No, not around. It is not around. No point having the name in the list. Obasara,
Yes, sir.
can you add your number also into the name?
I already add, sir.
Did you? Oh,
Yes, sir.
all right, we'll see. Chanuka Pereira? No. Thing is, if I remove the name, you can't join again. Neoka Ratnayaka. Neoka Ratnayaka.
Yes, sir.
Can you add your number into the name?
Okay, sir.
Rest is fine. Except that, who was it? Still the problem with Randhir. By the way, let me share the quiz marks that you have got so far.
பனி அதிகமா இருந்துச்சு, வெயிலே இல்லைன்னா வரும். ஸோ அது இதோ வந்து
Hope everybody has received this. You can see whether your name is there and then the marks have been identified. You see, for some names, these are the problems. So don't complain me later. Let's see, as an example, from this point to this set, as well as starting from there, this set, neither the registration number nor the NIC number. So that will have issues, but anyway, no, looks like they haven't attended to any of those meetings. Right. So this is how we have got marks so far. Okay. Right. Time is up. So time to start. Well, in the last meeting, we came up to the point hypothesis testing. Right. I think we went through formulating H naught and then HA. Right. I think that's where we stopped. We took an example like P is equal half, and then P is not equal to half, as an example. Remember studying a suspicious coin? And then for the study, we can formulate the null hypothesis and alternative hypothesis of the form H naught P is equal half and HA P is not equal half. Right. And then I think we had a kind of a discussion. If you think of tossing a normal coin, according to the null hypothesis, the meaning is half the time we observe heads and then the balance half the time we observe tails. So that if we just think of tossing a coin 50 times, normal coin, then what is expected is that 25 heads and 25 tails. But the thing is that in general, we don't get exactly 25 heads and 25 tails. Okay, from a normal coin, when you toss the coin for 50 times, you usually don't get exactly 25 heads and 25 tails. So that we see from a normal coin also, we don't get exactly 25 and 25 tails. So that from not normal coin or an abnormal coin, anyway, we will get these numbers different from 25 and 25. Isn't it? I think we discussed this point last week also. If you just think of a normal coin and then tossing it for 50 times, what is expected is a normal coin I'm talking about. So if it is a normal coin, we know probability of observing it is half. So then what is expected is that 25 heads and 25 tails. The thing is that we don't get 25 heads and 25 tails. We can easily get 23 heads and 27 tails. So we can easily get 21 heads and 29 tails likewise. So now the question is that even from a normal coin, we don't get 25 and 25. And then from an abnormal coin, anyway, we don't get 25 heads and 25 tails. So now the question is that how do we distinguish a normal coin from a true coin? Isn't it? This is the challenge. From a normal coin also, we don't get exactly 25 heads and 25 tails. In the sense that, let's say, with 50 heads, suppose you had 23 heads and 25 tails. Another time when you toss it for 50 times, that time you might get something like 21 and 29 likewise. Every time you don't get exactly the same number of heads and same number of tails. Anyway, you don't get 25 and 25, and then every time you find it to be different. What is the reason for this? No one can explain this. Isn't it? This is unexplained variability. Cannot explain that. Sometimes this is termed as error. Nothing wrong with this. By nature, this is the case. Okay. In fact, this can be called as better term is random variability. Cannot be predicted. Random variability. Right. Now back to the point. Because of this random variability, we don't get exactly 25 and 25. We can easily get a number like 23 and 27. So now thing is that, of course, from an abnormal coin, we get numbers different from 25 and 25. Now the question is that, challenge is that, how do we distinguish a normal coin from not normal coin? Same example. So we said we can easily observe 23 and 27, 23 heads and 27 tails. We can easily. So then, whenever we come across something like 23 heads and 27 heads, or the 24 heads and 26 tails, what is our conclusion about the coin? Our conclusion would be like the coin is a normal coin, because from a normal coin, you can easily get something like 23 heads and 27 tails. Isn't it? Easily get. Right. And if I just post something like 1 head and 49 tails. 1 head and 49 tails. 1 H and then 49 tails. What is your conclusion about the coin? 1 head and 49 tails. I am sure everybody will say coin is a false coin, or this coin is not normal. Earlier, what did we say? 22 heads and 28 tails. And then I suppose everybody will say that coin is a true coin. 22 and 28 coin is a true coin because such a number can easily be expected from a normal coin. But 1 edge and 1 head and 49 tails is something we do not expect from a normal coin. But if I ask the question, is it impossible? No, it is not impossible, meaning that is also possible. But the thing is, we usually don't come across that kind of an extreme outcome. Such an outcome, we usually call it to be an extreme outcome. So that if we happen to come across such an outcome, since it is normally not possible from a normal coin, usually it is not possible from a normal coin. Because of that, most probably we conclude the coin to be what? False coin. Isn't it? Right. So that 1 edge and 49 tails, false, 22 edge and 28, true. 1 edge, very extreme, isn't it? How about 10 heads and then 40 tails? Well, one might say still it is a false coin. Or otherwise, another person might say that it's a true coin. Now, this is interesting then. One outcome, 10 heads, and then 40 tails. One person is telling it is false, another person is telling true. Or it's possible 10 heads and 40 tails, person is telling that, or everybody is telling that it's a false coin, that's fine. If that is the case, let's say 15 heads and then 35 tails. It's possible one says false, another person says it's true. Right. From this discussion, I suppose we can notice two, well, hitting points. Starting from, if this is the case, most probably everybody says it's false. This is the case, most probably everybody says it's true. Something like this. Some might say it is false, some might say it is true. Isn't it? That's how it is. Right. So what are the two hitting points? One is that if it is extreme, conclusion is what? False. If it is extreme, conclusion is false. That's number one. If it is not extreme, true. Extreme, false, and then not extreme, true. False. What is false? This is false. What is that? H0 is false. Isn't it? H0 is false. P is equal half mean H0. H0 is false. Otherwise, H0 is rejected. And then not extreme, true. Otherwise, H naught is not rejected. That is one point. What is the other point? Is that decisions are based on cutoff points. Decisions are based on cutoff points. And it varies between individuals. Yeah. Just think about yourself. I suppose, this is how we take decisions in day-to-day life. I don't think, you ever thought it this way, but now if you start thinking, this is what is happening, isn't it? See, our decisions are based on cutoff points. Cutoff point, and then anything below the cutoff point, you call it what? Extreme. If you want to call it something extreme, obviously you have to have a cutoff point. But interestingly, this cutoff point varies from person to person. Now imagine in the second case, second example in sense that second illustration is that 15 heads. One says it is false, another person says it is true. Is that interesting? After tossing a coin, suppose the outcome was 50 heads and 35 tails. One person says it is a true coin and another person says it is a false coin. Just a minute. Okay. One outcome, but one person says it is false, other person says it is true. Is that interesting? Not only interesting, I mean, in a way, it's funny as well, isn't it? Same outcome. Two different outcomes, one is telling true, the other one is telling false. I mean, that's at least up to a certain extent, that's fine. But same outcome, one person says it is true, another person says it is false. Right. So it's subjective. Somehow, this is how it happens. Hypothesis testing is not exceptional. Even in hypothesis testing, decisions are based on cutoff points. Cutoff points are usually associated with extreme values, isn't it? Anything below that, obviously it is extreme, and then anything above, we call it not extreme. Okay, it's based on cutoff point. But the problem is that cutoff point varies from person to person. So to get rid of the problem, or otherwise to overcome the challenge of that, cutoff point varies from person to person. In hypothesis testing, cutoff point is decided based on probability. Based on probability. So that given the probability, everybody will have the same conclusion. Everybody will say whether it rejects or not, according to the probability. That is the purpose of, or otherwise the advantage of deciding the cutoff point based on probability. Given the probability, everybody will have exactly the same conclusion. Right. Maybe as an example, let's say, and then remember, already said that the cutoff points are usually associated with extreme values, isn't it? If it is extreme value, what is the probability of having such an outcome? High or low? Extreme. Probability is low. Isn't it? Extreme in the sense that, well, very often you don't get that. Usually you don't get that. That's why we call it extreme. Extreme values are associated with low probabilities. So, as an example, let's say probability of 0.1, probability of 0.1, small probability, or otherwise probability 0.05, even smaller than that. Obviously, values associated are extreme values because probability is small. So now the approach is that given the probability, you identify the cutoff point. As an example, let's say the distribution is the Z distribution. And then P is maybe 0.1. Very 0.1. Let's say somewhere there. 0.1. So small probabilities you will find the tail area. Center area associated probabilities are large. 0.1. Now, according to this 0.1, you can find C. Isn't it? That is what you did in the homework. Hope everybody attended to homework. Probability Z less than C is 0.1. How much is C? Remember? Hope everybody answered to those questions in the homework. That's why I gave that homework. See? So now we have the cutoff point C. So that if the observed value is less than C, reject. And if the value is greater than C, do not reject. Is that clear? So this is what is meant by cutoff point based on probability. Okay. First you decide the probability value, and then according to that probability value, you will decide the cutoff point. So it's not based on an observed value, but it is based on probability. So now we can see, like in the case of homework, now in the homework, everybody has same answer. What do you mean by that? Given the probability, everybody will have exactly the same cutoff point. Cutoff point cannot be. So then, Same conclusion. Whether H naught is rejected or not is consistent. Everybody will have exactly the same conclusion. Okay. And we were talking about like previous example. If you link that previous example to making a decision. Now remember, we said number of heads. 15 heads. 15 heads. So we need to find the cutoff point in terms of the number of heads. Number of heads. Suppose this is the distribution of number of heads from 50 tosses. 50 tosses. Okay. So we need to find now cutoff point such that this p-value is 0.1. Otherwise, yeah, let's say 0.1. So this is the cutoff. In terms of number of heads, how can we find the probability? Isn't it? What is C in terms of number of heads if the probability is 0.1? Isn't it? As the way we have discussed, first thing is this number of heads. No, I'm discussing the principle. Whatever the observed value, convert that into Z value, isn't it? Convert that into Z value. And then see that the Z value corresponding to 0.1. So this is the Z value, observed value after converting that into Z. Let's say Z observed. And then, as the way we discussed in the homework, given the probability, we can find C. So thereby we can find ZC. So that if Z observed is less than ZZ, what do we do? Reject. Reject H naught and do not otherwise. That's it. If you take this probability, which is cutoff probability, let the cutoff probability is 0.05. Cutoff probability is 0.05. Then how much is C? Then ZC is how much? Now from the table you can find that, isn't it? I think in the homework also you found same question. Suppose everybody can find ZC is minus 1.65. So that if Z observed, therefore, if Z observed is less than minus 1.65, what do we do? Reject. Do not otherwise. Isn't it? Right. Well, we were talking about one head and then 49 tails. We said if that is the case, the point is a false point. How about 49 heads and one tail? 49 heads and one tail. I suppose in that case also what we would say is point is a false point. So that you can see we can have cutoff point not only from one side, we can have cutoff point from both sides. Isn't it? Left hand side as well as from right hand side. Because one head out of 50 as well as 48 or the 49 heads out of 50. Either with very few heads or otherwise with large number of heads. Our conclusion is point is a false point. So that we can have cutoff point from both sides. So that if you say as an example, suppose now we said earlier cutoff probability is 0.05. Probably 0.05. So that this side 0.05 and this side also 0.05. So that this side minus 1.65 plus 1.65. So then we can say if Z observed value, Z observed is less than minus 1.65 or otherwise Z observed is greater than plus 1.65, H naught is rejected. Do not. This can be called as what? Rejection rule. Rejection rule. Then, as simple as that. So, for any observed value, what we do is anything to do with probability, what we do is we calculate the Z value, isn't it? We calculate the Z value. So that based on Z value, we can come up with a rejection rule. And then if you take if cutoff probability is 0.05 from both sides. Both sides. This side as well as this side. Both sides 0.05. So one side 0.025. Now how much is cutoff point? Left hand side minus 1.96. This side plus 1.96. So that we can say rejection rule. If Z is less than minus 1.96 or Z is greater than plus 1.96, reject H naught, do not otherwise. Instead of writing two statements, Z less than minus 1.96, Z greater than plus 1.96. We can combine the two sentences to say if Z in terms of absolute values greater than 1.96, reject H naught, do not otherwise. Is that clear? Right. The cutoff probability is usually denoted by alpha. Usually denoted by alpha. Cutoff probability usually denoted by alpha. When you say cutoff probability, if we are talking about all together cutoff probability. When you say cutoff probability, it is all together. So that half the value we find on left hand side and the balance half we find on the other side. So that all together is alpha. So that on one side we have alpha divided by 2. Now remember previous example, we had alpha to be 0.05. When alpha was 0.05, we found what? One side, alpha divided by 2 means 0.025. Therefore, on one side, alpha divided by 2, which is 0.025. And he said 0.025 to be minus 1.96. From left hand side, it is minus 1.96. Is that clear? So that in general we can say thus in general rejection rule is if Z in terms of absolute values greater than Z alpha over 2. Now when you say Z alpha over 2, we are talking about positive value. We are talking about positive value. So this is from left side. So if Z is greater than Z alpha over 2, reject H naught, Do not otherwise. So now alpha can vary from person to person. Alpha can vary from person to person. So that's why we generalize it. One might take alpha to be 0.05, another person might take alpha to be 0.01. Oh, one more person can take alpha to be 0.1, likewise. That can vary. So to accommodate that subjectivity, we can formulate the rejection rule to be of this form. If Z is greater than Z alpha O, if Z in terms of absolute value is greater than Z alpha O2, reject H naught and then do not otherwise. Okay. This is what is meant by hypothesis testing. As simple as that. That's it. Let's take an example. Let's say H naught mu is equal 60. HA mu is not equal 60. And let's say we found y bar to be equal to 70. Okay. And then sigma is equal, sigma square is equal to 25. And then n is also, n is okay. N is also 25. So now, what is our conclusion? Are we rejecting the null hypothesis or not? And let's say alpha is 0.05. In fact, usually in hypothesis testing, this alpha, what is this alpha? Alpha is that cutoff probability. Alpha is taken as usually or conventionally is taken as 0.05. But there is no hard and fixed rule. Some studies, depending on the study, later we'll discuss about that reason behind that. Some people go for smaller probability because some are very conservative, so that they go by like very small probability. Sometimes like 0.01 or 0.001, likewise. Okay, fine. Now let's see. Whenever alpha is 0.05, so that what we want is, what is the link? Link between variables and probabilities, what is it? So what we want is Z value. Let's calculate Z value. Z is equal, now remember, y bar minus H naught. Y bar minus H naught. Sorry. Z, remember definition, y bar minus mu divided by sigma square divided by n whole thing square. So this is how we get the Z value. Now, let's substitute values. Y bar is how much? 70 minus mu. How much is mu? Do you know mu? No, we don't know mu. We don't know mu. Now, if H naught is true, if H0 is true, then mu is how much? 60. Isn't it? If H0 is true, then mu is 60. So then if H0 is true, by having H0 value in the place of mu divided by sigma square divided by square root should have the Z distribution. Hope everybody followed that argument. Now you see we don't have mu. What we said is that y bar minus mu divided by sigma square divided by n square root whole thing will have what distribution? Z distribution. We said that is how we convert normal distribution into standard normal distribution. By the way, what distribution did we convert? Sample mean distribution into Z distribution. This is how we convert sample mean or sampling distribution or sample mean distribution into Z distribution. So in the absence of the true value, if we have only the hypothetical value, null hypothesis, so that if the null hypothesis is true, then with the null hypothetical value, we should have what? This is distribution. Because H0 is true. H0 is true means that the mean is how much? Null hypothetical value. With the true value, we have the Z distribution. So that if the null hypothetical value is null hypothesis is true, then the mean has to be what? That value. So if mean is that value, with that value, then we should have the Z distribution. What do you mean by Z distribution? If this is true, then the probability associated with this Z value should be large. See? If that is true, then the Z value that we compute should be a common Z value, not an extreme value. That is the principle. Okay. Should not be an extreme value. What do you mean extreme value? Extreme value means somewhere there. So that's why we said that we identify a cutoff point. So these are extreme values. So with the null hypothetical value, what is expected is that Z value to fall somewhere there. So if the null hypothesis is true, it should follow the Z distribution that Z value we should find somewhere there. It cannot be an extreme value. In case if it happened to be an extreme value, then what we thought as a null hypothesis has to be false. That's why we say we reject the null hypothesis. Okay, right. Thereby, we substitute null hypothetical value in the place of mu.
वो वहीं पे मैंने कमरे पे ही रखा है कहीं पे ये भी ले सकते हैं वैसे तो पानी चेंज कर ले
Consumo todo de nada com bem.
Well, we don't want to hear anybody's personal conversations, so that please keep all the mics muted. Manur, please keep the mic
तो यही
muted.
रोड है ना पप्पा
Agora, Cetana,
Manur, Nadir,
ये वही है ये तीनों के कपड़े चुराने वाली थी
interesting. I don't know why I can't.
देख लिया किसी से कल मिल जाते
Recording it.
अच्छा अच्छा दाल का तड़का
Manhur, Nadir, Keep the mic muted, Nadir. Okay, right. So let's complete the calculation. 10 divided by sigma square. Sigma square is how much? 25. And then n is also 25 square root, which is 10. Now, if alpha is equal 0.05, Z alpha over 2 is 1.96. Now we find, since Z value in terms of absolute value is 10, is greater than Z alpha over 2, which is 1.96, H naught is rejected. H naught is rejected. Thus, this is in statistical terms, H naught is rejected. Now, you know the meaning of H naught is rejected and not rejected. But the thing is, if a person does not have any understanding about statistics, that person would not understand the meaning of this rejected and not rejected. So that it is good to have our conclusion in layman's term also. Our conclusion or our interpretation in layman's terms also. So that we can say, true mean is, now you see we reject the null hypothesis. What do you mean by that? We go by alternative hypothesis. Okay. If null hypothesis is rejected, then that we accept the alternative. Okay. So the mean is different from how much? 60. Mu is different from 60. Further, since y bar is 70, is greater than
घुस गया अब मैंने कहा चल यार इसी दिन सब कुछ अभी आ गया मैंने कहा ला बस
greater than 60, it can be concluded that mu is greater than 60. Not only mean is different from 60, since sample mean is greater than the null hypothetical value, then hang on, H naught mu is equal 60. It can be concluded that mu is greater than 60. Exactly. So this is what is meant by hypothesis testing. That's it, as simple as that. Homework. Y bar is 200. Sigma square is 400. N is 30. Test H naught. P is equal 175 versus HA, mu is different from 170. Use alpha is equal 0.05. So that is a homework. In addition, you can say interpret the results. First, you make the conclusion in statistical terms, whether you reject the null hypothesis or not. And then, well, what is meant by that in layman's term? In day-to-day words, what is meant by that? Right. Now you see, at the end, our conclusion is that either we reject the null hypothesis or otherwise do not reject the null hypothesis. And there specifically in the question, I have said that test H naught. Why do we call this as test? Right. Now you see, what we did was in the previous illustration, we calculate the Z value using the null hypothetical value. It's not the true value. We didn't know the true value. We calculate the Z value using the null hypothetical value. What we said is our argument was that if the null hypothesis is true, then with that value, we should have the Z distribution. It says that the probability has to be large, or that this Z value we should not find in an extreme area, or the Z value should be fairly small. So if we happen to have this Z value falling in an extreme area, or otherwise Z value is extreme, then null hypothesis has to be false. Then we reject the null hypothesis. That is the idea. So that in the place of true value, we replace that value by the null hypothetical value. In such a case, we call it to be, we are performing a test. We are performing a test because thereby we are making an assessment. So that we call it, we are performing a test. And as you can see, with this assessment, what we calculated was Z value. Or otherwise, it is based on Z value. Because of that, we call what we have discussed to be Z test. What we discussed to be Z test. Cutoff problem. Yeah, this is exactly the point I was talking about. But the thing is that we in a classroom we cannot get the exact probability, isn't it? we cannot get the exact probability. Now, you see, Z value is 10 in the previous case. Now the question is that what is the Z value less than or equal to 10? Z value less than or equal to 10. Using Z table, we can find the probability. But as you know, for an increment of Z value 0.01 or 0.02. Okay. So based on this probability, this approximate probability, we can decide whether the probability is small or large. Now, earlier what I said is that if the null hypothesis is true, we should find this Z value, or we should find, after replacing the mu by the null hypothetical value, we should find what? Z distribution. What do you mean by Z distribution? We should find this Z value to be not in an extreme area. Not in an extreme area. Or the Z value should not be large. If the Z value is large, what is this probability? This probability is going to be small. This probability is going to be small. So that if we want this, once we have the Z value, we can calculate, or we can find from the table this probability value. If this probability value is small, this value is small in the sense that this is in extreme area. And thereby we can reject the null hypothesis. Thing is that we may not find an exact p value, but an approximate Z value, because this that's the approximate probability value. Because thing is that from a table you cannot get the exact probability, but roughly you can have that. So by looking at that probability, you can make the conclusion. Yes, no problem. But the thing is, what do you mean by probability small or probability large? This is where we said the cutoff point is based on probability. Remember we said that cutoff point is based on probability. So now if this is alpha divided by 2, now if I ask the question, what is the probability Z greater than or equal to Z alpha over 2? What is the probability Z greater than Z alpha over 2? Is alpha over 2, isn't it? Is alpha over 2. Deciding the cutoff point. Deciding the cutoff point is based on extreme values. Based on extreme value. So anything less than that probability can be called as extreme probability. So that if P Z value is less than in terms of absolute values less than alpha, that is from both sides, H naught is rejected and do not otherwise. In fact, with the use of computers, this is what we do, because computers give exact probability. computers give the exact probability. When the computer, well, when the computer finds the Z value from that formula, computer immediately convert this into P value, and P value is given. So according to the P value, we should decide whether to reject the null hypothesis or not. So inside the classroom, what you do is, we just go by the cutoff point. Cutoff point can be found from the table corresponding to alpha. So that is the usual practice inside the class. But if you are sitting in front of a computer, then it is based on probability. Okay, right. Right. So that we can say what we concluded is what? Z test. Z test. And then the topic was hypothesis testing. And now we can see that we can do hypothesis testing, or as we have discussed, performing hypothesis testing using the Z test. Why Z test? Because what we calculated was based on the observed value, what we calculated was Z value. Because normal distribution is assumed. When normal distribution is assumed, whenever we want to deal with probability, then what we want is the Z value. So that we got that to be the Z test. In fact, the Z value that we calculate, y bar minus h naught, and then sigma square n square root this Z value is called Z statistic. That value is called Z statistic. Why? Not the Z value, but the Z statistic. Why? Because we have used the null hypothetical value, not the true value. Because we have used the null hypothetical value, not the true value. So that we can call it to be Z statistic. Okay, fine. So we have now completed or discussed Z test, okay, Z statistic, and then rejection rule, and then interpreting the outcome, whether to reject the null hypothesis or not. Right, so that is what is meant by hypothesis testing, and then I have given a homework also. I think with that you will look that also, you will have more understanding about how to perform that and then making a conclusion. Let's talk a bit about different situations that we come across in hypothesis testing. What we have discussed so far is that based on the observed value, you calculate the Z, well, you have the observed value, and then you convert that into Z statistic, and then see that whether the Z statistic falls in the critical region, or not. So this is the cutoff point. This is the cutoff point from the left-hand side. CL, CR. So if the statistic falls somewhere here or otherwise there, we reject the null hypothesis and do not otherwise. Isn't it? Now you look at the distribution. Distribution goes from this point to this point. So somewhere here also you can have values from this distribution. Values from this distribution. Starting from there, you find values. Starting from this point up to this point. See? Now, in terms of sample, we are talking about sample mean distribution. Sample mean distribution. Okay, before converting into Z, sample mean distribution. So we can find the cutoff points in it. Homework, yeah, we can find the cutoff point CL, CR. And then see whether our sample mean falls within the critical region or not. See? If it falls somewhere here, reject. Otherwise, do not otherwise. Now we can see sample means you can have from this point to this point. So it's possible that sample means you find somewhere there also. But the thing is that if we happen to have sample mean from this area, mean of this distribution is what? H naught, mu naught, null hypothetical value. So if the null hypothesis is true, we should find our sample mean to be somewhere there, where the associated probability is large. But the thing is, it's possible that we have an unlucky sample. Unlucky sample, of which the sample mean is somewhere there. Now, in reality, we can have sample mean values from this place to this place. So, according to the criterion that we have established, anything less than this, as well as greater than this, what do? We reject. So, it is possible this sample mean, our observed sample mean, actually belongs to this distribution. Actually belongs to this distribution. What is this? Null distribution. Null distribution. According to the null hypothesis. Distribution according to the null hypothesis. So it's possible the sample mean actually belongs to the null distribution. But since our sample mean falls somewhere there, our conclusion is what? The sample mean does not belong to this distribution. Thereby we say it belongs to a different distribution of which mean is different from mu naught. So that we reject the null hypothesis. Did everybody get that? What I said is that? It's possible this sample mean actually from this distribution. But because sample mean fell somewhere there, according to the criteria that we have established, our conclusion is what? Reject. But should we reject? No, we should not reject. Why? Because that sample mean also belongs to this distribution. We should not reject. But according to the criterion that we have established, rejection rule that we have established, we reject the null hypothesis. And thereby, what do? We are committing an error. Isn't it? if that sample mean actually belongs to the population in concern or null distribution, we should not. So if we happen to reject, we are making an error. Isn't it? So it's possible we commit errors in hypothesis testing. Hope it is clear. So that we can see it is possible that we commit errors in hypothesis testing. And if I ask you, what is the probability of committing that error? What is the probability of committing that error? Now, what are we talking about? Sample mean falling there. Sample mean falling somewhere there. Now, the question is, what is the probability of falling sample mean there? This critical region is what? Now, remember earlier we said this area is how much? Alpha. So that probability of committing this error is alpha. Now, isn't that interesting? Now we see earlier, what was the interpretation? What is the description about the alpha? Alpha is the cutoff probability. That's how we define alpha, cutoff probability. And now we are having a different definition for alpha. What is alpha? Alpha is probability of committing that error. Probability of committing that error. What do you mean by that error? Is that rejecting the null hypothesis when the null hypothesis is true. I said sample mean actually belongs to population concern. So the null hypothesis is true. But we are rejecting. Okay. So probability of committing that error is alpha. See. Earlier we went by what? What is alpha? Alpha we said the cutoff probability, but now we have a different interpretation for that. Alpha is what? Probability of committing that error. In fact, not only that error we come across in hypothesis testing. We come across another type of error in hypothesis testing. Let's say this is the null distribution, mu naught. So we have cutoff point. CL, CR. Now, see, this is not the only distribution exists on the whole earth. There are so many other distributions. Infinite number of other distributions. Now, if you think of one such distribution, we may have it like this, another distribution. So that we can call this is one of the alternative distributions. So the mean is then mu A. One of the alternative distributions. Now recall, how did we call this area? Alpha. How did we interpret alpha? Alpha is probability of committing the error that we reject the null hypothesis when the null hypothesis is true. When it is true, we should not reject. Isn't it? If it is true, why should we reject? If it is false only, we should reject. The thing is that if you reject, when it is true, committing an error. That was what we discussed earlier. And then, on the other hand, if it is false, we should reject it, isn't it? If the sample mean actually does not belong to the population concerned, we should reject it. Now you see, with the red distribution, alternative distribution, values start from this point and goes up to this point. Isn't it? So it's possible we have a sample of which the mean falls somewhere here, somewhere there. It's a sample belongs to, sample mean belongs to the alternative distribution and falling somewhere there. If it falls somewhere there, what is going to be our conclusion? According to the criterion that we have established, anything below this CR, what is our conclusion? They all belong to the blue distribution, null distribution. So that it is possible that sample mean actually belongs to the alternative distribution, but without rejecting it, we conclude that sample mean also belongs to the null distribution. If it does not belong to the null distribution, we should reject it. But if we do not reject it, thereby also we are committing an error. See, earlier what we said is that null hypothesis is true, but we are rejecting. Now, null hypothesis is actually false, but we are not rejecting it. If it is false, we should reject it, but we are not rejecting it. And now, what is the probability of committing that error? Is the area under the red curve is this. Since the probability associated with the previous error we denoted as alpha, the probability associated with this error is denoted as beta. After alpha, the letter we have is beta in Greek alphabet. So these are the key two types of errors that we come across in hypothesis testing. First one is that rejecting the null hypothesis. Errors. First one, rejecting H naught when H naught is true. Second, not rejecting H naught when H naught is false. These are the two types of errors. Right. Do we need to commit errors? No, nobody wants to commit errors. Isn't it? We don't want to commit errors, but we want others to commit errors, not us. Right. So that we always try to avoid committing errors, or at least minimize the probability of or the possibility of committing errors. Now, if you go by the first one, alpha, one type of error. So if we want to minimize probability of committing that error, we can decrease alpha. It's a matter of decreasing alpha. We want to decrease alpha. What do you have to do? I think I need to get back to the screen. is the null distribution. And this is the alternative distribution. A. Suppose cutoff point is somewhere there. So this is what? Alpha. And similarly, this is beta. So now, if you want to reduce alpha, what do you have to do? We need to shift this cutoff point towards what? Right. So the new cutoff point will be somewhere there. So then how much is alpha? Alpha is only this much. But then what is happening is that, yes, we have decreased alpha. But then what has happened to beta? Now beta starts from this point. Isn't it? Now beta starts from this point, so that beta will be larger than earlier. Similarly, if we try to decrease beta, then we need to shift this cutoff point towards left, so that we can have the new cutoff point somewhere there. Of course, beta will be only this much. Beta will be only this much. But the thing is, then alpha starts from here. Alpha increases. This is what is happening. See, the challenge is what? When we try to decrease one error, the other error increases. The reason is that two errors occur opposite to each other. That is the reason. Two errors occur opposite to each other, so that when you try to decrease one, the other increases. How do we overcome? I suppose in day-to-day life also, we come across sometimes this kind of situations. We have two types of errors. Thing is that we cannot avoid both. If we avoid one, we are committing the other. If we avoid first one, we are committing the second error. If we avoid the second one, we are committing the first error. You can't help. Isn't it? It's like, usually I take the example, especially being a student, as you know, sometimes you borrow books from the libraries. And in the library, you have two types of lending books. Lending that you can keep it with you for some time. Lending. One type is that you can keep the book for about 2 weeks. Other type is that you can keep the book only for overnight. Only for overnight. So let's say you have borrowed an overnight book. Overnight book. And then the regulation is that, well, before 8 o'clock in the following day morning, you need to return that book to the library. Before 8 o'clock in the following day morning, you need to return that book to the library. That is a regulation. And as you know, we start lectures also at 8 o'clock. Suppose, due to some reason, by the time you reach the university, it was exactly 8 o'clock. And then the book that you have borrowed on the previous night is still with you. Now it is 8 o'clock. So otherwise, almost 8 o'clock. Just before 8 o'clock. An interesting thing is that you cannot return the book after 8 o'clock, then there will be a fine. And then the lecture also starts at 8 o'clock. Attending to lectures after 8 o'clock is an offense. Isn't it? Not returning the book is also not returning the book on time is an offense. Similarly, not attending to lectures on time is also an offense. Now it is almost 8 o'clock. Thing is, if you go to the library now, you can return the book and thereby you can avoid that error, that offense. But the thing is that you will not be able to attend to lectures on time and thereby you are committing that error. Other possibility is that you can attend to the lecture, but then the thing is that you won't be able to return the book on time. Thereby you are committing the other error. Isn't it? Can you avoid both? No, not that you can avoid both. Thing is that this is not something you pre-plan. Maybe because of the weather, or otherwise the bus that you were traveling, suppose from the whole, you were traveling, maybe from Inagala Hall, otherwise from Ramanathan, you were traveling, or that's from Mahakanda, you were traveling. Thing is that problem with the bus, so that you have to wait for another bus. Thereby, you got late. Maybe 5 to 10 minutes you have late for the second bus. Because of that, you got late. Not that, you expected this. Day-to-day life, these things happen. Now the thing is that you will have to commit at least one error. You cannot avoid both. Now what would you do under this kind of circumstances? Maybe another situation is that let's say a dog is coming to bite you. A dog is coming to bite you. Do you want a dog to bite you? Obviously not. Now you need to avoid that. In order to avoid that, one possibility is that, let's say you have umbrella or something. So you can hit the dog and thereby you can chase the dog away. Otherwise, let's say you have a gun. You can kill the dog if you want. And thereby also you can avoid that dog biting you. Okay. Now you see, you have a choice. Either by hitting the dog or by killing the dog, you can avoid that dog biting you. What will you do? Or similarly, if you want to extend that, suppose somebody is coming to kill you. And person is having a gun. Person is coming to kill you now. Let's say you also have a gun. You can avoid that person killing you. You would get killed by another person. Obviously not. You can avoid that person killing you. Let's say you have a choice. Either by killing that person, you also have a gun. So you can easily kill the person. Or by hitting the person. Hitting also, you can avoid that person killing you. What will you do? Killing a person or hitting the person? Or otherwise hitting that dog, otherwise killing that dog. What will you do? I suppose in the normal world, well, by the way, it's because you want to avoid something, not that you want to kill people or otherwise dogs. What I said is that person is coming to kill you. Or otherwise, that dog is coming to bite you. That's what I said. So to avoid that, what I said, two possibilities are there. Even if it is to prevent, you are getting hurt. what we usually do is that out of a choice, we usually decide what? Less serious one is when we usually commit what? We commit the less serious one. Now, you see, what do you mean by less serious one? See, killing a person, of course, the person is coming to kill you, but killing a person is supposed to be an offense, isn't it? I mean, sense that if you, even if you hit a person, but hitting a person is an offense or not? It is an offense. So if you hit the person, police will come and arrest you. Isn't it? Later only, you can prove it that you were innocent. Later, that is in the courts only you need to prove that you are innocent. But otherwise, the police will catch you. Killing a person is also same. You can say that it's because you want to avoid something, but that has to be proved in the courts. Otherwise, you will be considered as you also have committed an offense. That's why police will catch you. Right. Because of that, normal circumstances, since you need to commit at least one offense, in this case, to avoid you are getting hurt, we will be selecting the one with less serious. Say, you avoid the more serious one, but commit the less serious one. That is the usual practice. That is what is happening in the real world. You cannot avoid both. You will have to commit at least one. So that in such a case, what we select is the less serious one. Don't talk about final exam now. Talk only about the subject matter now. Okay. We'll talk about this at the end of the class. You see, when I open it up, any comments, concerns, that is the time you need to come up with, this kind of questions. Okay. Right. Otherwise, you see, disturbing. Right. Back to what we were discussing. Whenever we have to commit at least one, usually what we decide to commit is the less serious one and then avoid the more serious one. Now we have a similar situation again. We have two types of errors. One is rejecting the null hypothesis when the null hypothesis is true. The other one is that not rejecting the null hypothesis when the null hypothesis is false. So now the question is that out of the two, which one is less serious and which one is more serious? Okay. Which one is more serious and which one less serious? So if we can identify the one with the one which is less serious, then we can think of committing that one and then control the other one, the more serious one. The question now is that which one is more serious and which one is less serious? Very often we take the situation of court trial when it comes to explaining well, what to select out of the two, or to decide which one is more serious and which one is less serious. Suppose the case is after a murder. Now the police has produced a person in the courts. How do you call such a person? Suspect or the defendant. Now the case is about to be heard. Case is about to be heard. Everything is set and the case is about to be heard. Right. at that point, so this is a starting point. At this point, or at the initial stage, what is the opinion about the defendant? Is the person guilty or otherwise innocent? The person guilty or otherwise innocent? Now see, the police has produced this person in the courts. Do you think police catch people randomly? No, they don't catch people randomly. They also look for information. Usually such information is called evidence. They look for information, then only they catch people. After that, they produce them in the courts. They can't punish people. Only the court can punish people. So they have to produce such people in the courts. Right. So my question was that, what is the initial opinion about the defendant? Is the person guilty or otherwise innocent? In fact, the initial opinion about the person is innocent. That's how we have the law. Until the person is proven guilty. Until the person is proven guilty, the person is innocent. Proven guilty in the sense that, in fact, giving the verdict in the courts. Giving the verdict in the courts. That is what is called. It is proved that the person is guilty. Okay. In fact, the decision is about whether the person is guilty or not. Whether the person is guilty or not. See, I think on the other day also, I think I mentioned this. I hope so. Either we reject the null hypothesis or we do not reject the null hypothesis. What is the opposite of reject? Accept. See, I never use the word accept. I said we either reject the null hypothesis or we do not reject the null hypothesis. I use the word accept. Okay. What is the reason behind that? Is that when it comes to rejecting, we are very, very firm on that. We are very firm, we are very sure about that. We have enough evidence to reject the null hypothesis. But if we do not have enough evidence, all what we can do is we cannot reject the null hypothesis. If we have enough evidence, we reject the null hypothesis. If we do not have enough evidence, we do not reject the null hypothesis. It does not necessarily mean the null hypothesis is true. See? Yeah, maybe we can better explain that with that court ruling or the court case. Since that the way the judge makes the conclusion is that either the person is guilty. See, the way the judge makes the verdict is that first form. Two forms are there. Okay. Two statements are there for judge to make, and then the statement is always one of the two. What are the two statements? One is that there is enough evidence to say that the person is guilty. Other one is what? There is not enough evidence to say that the person is guilty. That's all. Judge will make the statement one of those two forms. Either the first form or the two. First form is that enough evidence to say that the person is guilty. Second one is that not enough evidence to say that the person is guilty. But judge will never ever use the word the person is innocent. Is that clear? If sufficient evidence is there, judge decides the person to be guilty and thereby impose the punishment on the person. If not enough evidence is there, if not enough evidence is there, then that will say that there is not enough evidence to say that the person is guilty, and thereby person is free to go home, person will not be punished. Now remember at the beginning I said, the police do not catch people randomly. Thing is that sometimes they fail in proving that the person is guilty, or they fail in providing sufficient evidence. They need to convince the judge. But if judge feels that is not sufficiently convinced, then person is not punished. Person is not decided to be guilty. Okay, so this is what is meant by rejecting the null hypothesis and reject or do not reject. The word accept is not used. Accept in the null hypothesis is not used. Right. And then now back to the point of like which error is more serious and which error is less serious. If we extend that court trial, suppose it is after a murder. If it is after a murder, what is the punishment? Punishment is capital punishment. We terminate that person's life. Capital punishment. But somehow in Sri Lanka, we don't practice capital punishment, do we? No, we don't. In fact, a lot of countries do not practice. Some countries still practice. In US, some states practice and some states don't practice. So that's how we have. Say, even if a person has committed the offense, well, we don't impose the capital punishment. Right. Now, let's define the two errors with respect to this example. Null hypothesis is true, but we reject the null hypothesis. Meaning what? What is the null hypothesis? Person is innocent. But we reject means what? We decide the person to be guilty. See, those are the possible errors. Person is actually innocent, but we decide the person to be guilty. What is the other possibility? Person is actually guilty, but we decide the person to be innocent. Isn't it? Those are the two types of errors that we can come across from a court trial. Isn't it? First one is what? The person is innocent. Null hypothesis is true, but rejecting it in the sense that person is innocent, but we decide the person to be guilty. What is the second one? Null hypothesis is false, meaning person is actually guilty, but we do not reject, but we decide the person to be innocent. Those are the two types of errors. Now, out of the two, which one is more serious? Which one is more serious? When the person is innocent. When the person is innocent, we decide the person to be guilty and then we terminate that person's life. We are going to kill that person. That is one. That is the first error. And the other error is what? Person is actually guilty, but we don't punish the person. We decide or we declare the person to be innocent. So person is back in the free society. Which one is more serious and which one is less serious? Right. Now you see, first what I said is that in Sri Lanka, we don't practice capital punishment. We don't practice capital punishment. Even if the person is guilty, we don't impose the capital punishment. So imagine now sending an innocent person to the gallows, terminating that person's life. How serious it is. Now you see, terminating somebody's life, can we revert that process? No, we cannot revert that process. Right. Right. Now, interesting, isn't it? Why are we trying to kill that person? Because that person has killed another person. So at the end, altogether, how many are dead? 2 are dead. In a way, first one is accepted, but kind of first one is first killing. Why are we trying to kill that person? Is because that person has killed another person, which is considered to be an offense. Okay, but at the end of the day, it's like 2 are dead. Fine. See, killing the second person is why most of the countries do not practice. It is considered to be unethical. Now, see, in a way, it doesn't make sense, isn't it? Now, why are we trying to kill that person? It's because that person has killed another person. So, killing is not accepted. But as a punishment, you're killing a person. That's why most of the countries do not practice. Right. So, we usually convert in Sri Lanka as well as in most of the countries. When the capital punishment is imposed, immediately that punishment gets converted into what? Life imprisonment. Lifetime person has to be in the jail. Okay, life imprisonment. So that is how it happens. Right. And on the other hand, we decide we decide the murderer to be an innocent person. So person is back in the free world. Now, what is the problem with that? Problem is that, well, why are we, in fact, punishing a person? Is it because, well, we are personally against that person? No, there's nothing like that. It is a lesson to the whole society. That's why we are imposing punishments. Somehow now, see, the problem is that whatever the act, whatever we do, when it comes to doing it for the second time, you find it to be not that difficult. First time, you find it to be difficult. Anything, doing it for the first time, you find it to be difficult. But second time, it's not difficult. This is the problem. Human nature. This is the problem. So person is back in the free world in the sense that it's possible when you travel in a bus. Person you are sitting next to, the person sitting next to you, it's possible the person is a murderer. Yeah, because person is back in the free world. They have decided, see, because of that error, we have decided guilty person to be an innocent person, so that the person is back in the free world, so that it's possible you find that person sitting next to you is a murderer. How do you feel that, sitting next to a murderer? Will you
क्या हुआ?
go by that or anyway? See,
क्या वो अभी थोड़ी उठाएगा मानो
मावल से तो बात करो ना.
मागल से मैं अभी
this
क्या
is
बोलूं
this is the consequences of
जैसे पहले वजू करके नमाज
2
पढ़ के
types
आते
of
थे,
errors.
तो फिर आप बोल देखने लग गई.
करते थे जाने
आप भी तो वो देखने लगी वीडियो.
Okay. These are the 2 types of errors. Now the question is that out of the 2, which one is more serious and which one is less serious? I don't think we can have more time on this. Probably you all can organize a debate on this. I suppose in Sri Lanka also, we maybe a couple of years back, we came into a discussion, but did not proceed. Anyway, you can argue in both ways. You can argue in both ways. I cannot make any anymore, I think, probably because of setup as well as no time. Well, some of you might say that, well, first one is more serious than the other, or otherwise, first one we discuss is more serious than the other. And then the others might say the second one is more serious than the first one. Okay. You can argue in both ways. Yeah. Okay. And then it's a very sensitive issue. Sometimes, as you know, if it is in general, you might be sympathetic, but the thing is that if it is the victim is somebody related to you, then but your conclusion is that no, we should get rid of that person, we should punish that person likewise. Isn't it? That's a human nature, can't help. All right. So you can argue in both ways, but in reality, what is considered to be more serious is the first one. The first one is considered to be more serious. Is what? Rejecting H naught when it is true is considered to be more serious. Okay. So this is the first one we described. So it's called type 1 error. Other form is called the type 2 error. That is not rejecting the null hypothesis when the null hypothesis is false. But this is considered to be more serious. So that in hypothesis testing, now remember what we said is that reality, we always try to avoid possibility of committing more serious one. And then in case if you cannot avoid both, we let the less serious one to occur. Okay. That is the standard practice, so that we minimize the possibility of committing type 1 error. Since two errors occur opposite to each other, we control this one, or else we decide the value for this one, and then let second one to depend on the value that we have decided for the first one. We decide the value for alpha. We decide the value because we consider that to be more serious. So we decide value for alpha and we let beta to depend on the value we decided for alpha. Okay, so this is what we add up. So that the process of hypothesis testing can be summarized as H naught. As I said, that it could be true as well as false. It could be either true, otherwise false. Being it true, possible outcomes reject H naught and then do not reject. Reject and do not reject. False. Reject or otherwise do not reject. H naught, possible it is true, given it is true, reject and do not reject. Or the given it is false, reject and do not reject. If it is true and reject, what are we doing? Are we committing an error or making correct decision? If it is true, we should not reject it. So if we are rejecting it, we are committing an error, and this is what is called type 1 error. If it is true, do not reject. Yeah, if it is true, we should not reject. Meaning we are making correct decision. So this is called type A correct decision. H naught is false. Given it is false, or if it is false, should we reject it? If it is, of course, we should reject it. So that if it is false, if we are rejecting, it means we are making correct decision. Type B correct decision. H naught is false and do not reject. If it is false, we should reject. If we are not rejecting it, we are committing an error. Type 2 error. So this is how we can summarize the outcome from hypothesis testing. Okay, right. I think it's time to have a break. So we'll have a break and start.
Sir, excuse me.
Yes, before the break.
Sir,
Yeah.
can you send the previous class homework sheet, sir? That is not supported in my device last time, sir.
Homework or quiz?
That sheet, sir. That probability
The mark sheet.
homework sheet. Yes, sir.
Mark sheet. Oh,
Yes.
mark sheet. Yes.
Not mark sheet, sir. Previous class, sir. You send
Previous
in
class
the
what?
chat box
Sorry, you mean the
about
statistical
the probability
table?
question.
Statistical table I shared.
No, sir. Last week homework sheet.
Last week homework sheet. You mean those height values? The Excel sheet? Oh,
No, sir.
No,
After
sir.
that, another one, sir.
another one. What did I share?
That value,
Right.
probability value.
Okay. Now I remember. It's like tutorial. Yes. What happened?
Yes, thank you. That is not supported in my device, sir, last
Can
time.
I tell you? Can you talk to another person, who is following it, and then get it shared from that person? Ask that person to email it to you. Get hold of a person who is following the course, another person who is following. Now you see 100 and about 150 are following. Okay. Or otherwise probably send an email to computer unit. Let me give you. Okay. Probably this is. Drop me an email. Okay. Drop me an email to this address.
Okay, sir. Thank you.
Right. So let's have the break. Break is for another question. This is regarding examination. We'll talk about examination at the end. Screen is struck or not? What do you mean by? Carmelita, what is the problem? Can't you see the screen? Carmelita,
Yes, sir. Now, okay.
is it okay now? Okay, right. Good.
Okay now.
Right. Hope everybody's back. Shall we start?
Yes.
By the way, I still find, some names without numbers. Randhir, Lakmal, maybe Lakmal has left. WADT, Vikramasinghe. Who is it? Is it Randhir? No. Randhir Chandko Pereira? Sugat Tamarasiri? Sugat Tamarasiri? Sugat, can you add the number to your name? Interesting. Sampath. Sampath.
Sir,
Can you add your number to
yes, sir. At IN. Okay, sir.
did you attend to meetings earlier?
Yes, sir.
Okay, well, how did you have your name? Did you find your marks in that mark sheet?
No, sir. I
Ah.
cannot.
Did you attend to any of those quizzes?
Yes, sir.
You did. Did you
Yes.
find marks?
Yes.
Okay. But that time, did you have a number or otherwise?
Yes, I am.
Today also at that number?
Okay,
Same-
sir.
Same number.
Okay, sir.
Excuse me, sir. I am Chintana Abhisekar.
Who is Besekar?
Chintana Abhisekar.
Yes, Chintana.
On December 7th, I participated the quiz, but no marks available.
That's the thing, what name
My
did you
page number
appear
also.
by? Huh? Did you have your number?
Always I mentioned my number, sir. Number with my name.
Shall I tell you? Can you send me an email regarding
Okay, sir.
what number you use on that day? Then we have to use which registration number or the ID number?
Registration number.
Registration number. Okay. I will check that, because the what you call all
Sir,
quick answers are recorded, so that I
Okay,
have
sir.
all the answers. Yes.
Okay, sir.
I will check. So let me know the date and then the number. Okay.
Okay, sir.
Hello, sir.
Yeah. Anybody else having the problems?
Yes, sir. I already put in my problem also in the chat box. Is it okay, or should I send an email?
Better thing. I will check then. Yes. Better send an email. Because when I get out, I find that it's difficult.
Sir, actually, at the moment, I do not have your email address. Could you please share?
Where were you, when I wrote that?
Sir, at the first day, I
Hoping
didn't.
someone. No, about 5 minutes ago, I wrote that on the screen.
Sir's email address?
Yeah. Because somebody was asking something. Then I
Uh,
wrote the email address.
I'm sorry, sir, I didn't get it. I show in the screen 4 persons' name, Randhir, Lakmal, and
No, that is after the break. I displayed my email address, before the break. Did you join just now?
no, sir. I was in the session continuously,
How
but
come is that then? Meaning, that's, you see, now we are getting evidence.
actually, I don't know why it's missed from me. Actually, I continuously stayed here,
Mhm.
but I went out at the break, but I was in the
No,
screen.
it was before the break, probably, well, was
I'm sorry,
kind of
sir.
after announcing the break. Maybe you have ran away.
No.
Yes.
Okay, thank you, sir. Just for me, sir, can you please share it again?
You see, this is the evidence. See, you can't cheat, with systems, you can't cheat. Yeah. I will, okay. Yeah, probably let me finish with this. Where is this Randhir person? Randhir Chanduka Pereira? Not around? This Lakmal. No, Lakmal. I think now it is okay. Who was talking to me earlier?
I'm sorry, sir. Now I saw that.
Okay.
Sir,
Please,
actually, I left from the screen after sending my message into the chat. I don't know why I missed it. I'm really sorry, sir. I'll get now.
No, that's fine. No, that's why I said that. We have evidence. Who is this? Yeah, drop me an email, Niranjani. I will check and see. Those who have attended to quizzes, I have all the records. But if records are not there, your fault. Sometimes it's difficult to find because of, no number. Different days we appear by different names. This is the problem. So, Asna,
Yeah, sir.
what is this issue? Can't find your marks or what?
I didn't check my marks yet, sir.
Did you find your name in that list? Did you find your name in that list?
No, sir.
Meaning you haven't attended.
No, sir. I attended all the
Quizzes. What was the name that you used? Can't
The
remember?
similar name in the.
Did you use this number? 23218.
Yeah, sir. Yes, sir.
I will check and see, okay, because well, I went by the
Okay,
records.
sir.
So you see, it's good. That's why I thought of sharing this, so that you think I have your marks, but the thing is that actually I don't. Who is this? You haven't received the
Sir.
mark. What is Hasna? Haven't you received the mark sheet? What is this? Hasna?
Yeah, sir.
Well, didn't you receive the mark sheet?
No, sir.
Oh, how come is that? You check the chat box.
So I didn't take the marks, or I didn't see. That's why I'm asking whether it's uploaded any sheet or somewhere to check.
No, well, at the beginning of today's meeting, I shared the mark sheet. Did you join late?
Yeah, sir.
Okay. So you contact somebody who was present in the class and get it shared. Yeah. Another person was talking. Who was it? Quickly, running out of time. Sorry.
Sir,
Yeah. Who is it?
Sadish, sir.
Satish. Yes, Satish.
Yes, I also have the same problem, sir. I sent the answer to the quiz on December 8th, but I didn't get the marks, sir.
Really? I will check and
Yes.
see. Okay, right. Can you
Okay,
drop an
okay,
email?
sir. Yes, sir.
Yeah, so that I will not forget.
Okay, sir. Thank you.
Right. Satish, no problem. Right, shall we move on? What is this? Yes, Manur? Manur, Nadir? What is this? No, don't send messages now. Drop me an email to this email address. I will check and see, and then update the mark sheet. Okay, don't send messages anymore.
Hi, sir. Good evening.
Yeah, who is it?
Hello.
Is it?
Yeah, sir, this is Mahanur, international student. So, sir, the student who does not have a portal, what about them?
Sorry, say that again. Mahanur, yes. Yes, Mahanur, what was the issue? What is the issue?
Hello.
Yes, Mahanur, I can hear you.
Sir, I said, yeah. Sir, I'm saying the student who does not have the portal right now, like I don't have this access because I did not got my admission ID and everything. For that, I need to be in the country and apply for it. So what about us?
What do you mean by you don't have access to material? No, I'm sending all the material through the chat box.
I think our hearing, sir, what I can understand from all of this conversation, first of all, I'm so sorry. Right now, here in Pakistan, we don't have like a good connection. That's why the internet's constantly breaking. That's why I'm like trying my best. And right now, I'm literally standing on a street to get the signals and have my class. Yes, sir. Literally, there's some issue with the internet connection, massive issue.
By the way,
the thing that I'm asking is this, that from this conversation, all of this class, I thought maybe you are sending the, yeah.
Yeah, I shared the mark sheet at the beginning of today's meeting. Did you receive that?
Yes, sir. No,
You
sir, I
did.
haven't received it. It did not showed up.
Okay.
Yes, I thought maybe you are uploading those numbers on the portal, the student portal.
No, but if you have not registered, you will not have access to that portal.
Yeah, but no, I don't have access to the portal. There is other issues, sir, that I
That's
have
the
to,
thing. No,
manage once I get into the country.
no, the thing is that unless you register or until you register, you will not
Yes,
have
sir.
access to any of those portals.
Oh,
That is,
yes, 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 yes. That
that
is the
is
problem. Yes, sir.
so that
Yes, sir.
no, I have not shared, otherwise I did not share any document through the portal yet.
Okay, sir.
I was sharing, all the document through chat because I know
Okay, but
some of you haven't enrolled. That's why.
okay, sir. Okay, thank you so much. But still, that's the
Maybe,
whole problem that I still
maybe,
did
shall I
not
tell
got
you? Can drop me an email to my email address.
Okay.
So that I can share that document, the mark sheet, and so that you also can check and see
Okay.
whether
Okay, sir.
your marks have got entered. Okay.
Okay. Okay. Thank you so much. Thank you so much.
Right. Let's move on. Right. So this is the summary of hypothesis outcome from hypothesis testing. Right. Recall again testing hypothesis H naught mu is equal to A, HA mu is not equal to A. Okay. Now, what is the decision that we make at the end? Either we reject H naught or otherwise do not reject H naught. Isn't it? We make the conclusion either of the form reject H naught or otherwise do not reject H naught. Okay. If we do not reject H naught, what do you mean by that? Mean is equal to A. If you reject H naught, what do you mean by that? Mu is not equal to A. Mu is not equal to A. Isn't it? Why are we undertaking this study? Because need to know mu, isn't it? That's why we are undertaking this study. And then, if we do not reject the null hypothesis, we have an answer. But if you reject the null hypothesis, if you really think about it, all what we have is mu is not equal to A. Mean is not equal to A. It is like you are making a statement, price of something is not equal to 100 rupees. Imagine you told somebody price of a pen is not equal to 100 rupees. I bet that person will think in terms of like there's something wrong with you. Price of a pen is not equal to 100 rupees. Does it make sense? No, if you really think about it, it doesn't make sense. So that ultimately, when performing hypothesis testing also, we have produced kind of incomplete information in it. Mu is not equal to 60, or this mu is not equal to 100. But the thing is that we need to know how much mu is. So the question now is that, how do we answer that question? Because That was the origin of the study, isn't it? Need to know mean of the population, isn't it? Because understanding is that mu is equal to A, but we have found that no, it is not. It is different from A. So then the question is, how much is that? Isn't it? Natural question. We answered that question using the approach called confidence interval. We answered that question using the approach called confidence interval. Meaning, we make a statement of the form mean is between lower limit and upper limit with certain level of confidence. Certain level of confidence. Confidence, let's say confidence interval, CI. Confidence interval for mu. Oh my God. Mu is given by y bar plus or minus z alpha over 2 sigma divided by square root of n. Specifically said to be, since z value we have used here is corresponding to alpha over 2. Because of that, we call it specifically said to be 1 minus alpha times 100% confidence interval for mu. If, example, if alpha is 0.05, then this becomes 1 minus 0.05 multiplied by 100 is what? 95% confidence interval for mu. So that we have it like, let's say, 40 to 75. So this is lower limit, this is the upper limit. So if we have the interval, now you can see we have the answer to that question. How much is the mu? Now we know mu is neither less than 40, no greater than 75. And then we can go one step further and say that I am 95% certain that mu is between 40 and 75. This is how we interpret the confidence interval. I'm 95% certain that mu is between 40 to 71. If alpha is 0.01, then we are talking about 99% confidence interval. So likewise, we can decide the level of confidence. The principle is that we can answer that question. What are the possible values for mu? One might think of, well, we are 99% certain, or we are 95% certain, meaning 5% subject to error, isn't it? 5% subject to error. If it is 99%, only 1% subject to the error. So one might think of 100% confidence. One might think of then 100% confidence. So if you construct 100% confidence interval, then what we have is y bar 100% confidence interval, y bar plus or minus z. Then how much is alpha? Alpha is 0. 0 divided by 2 is 0. Sigma divided by square root of n. How much is z 0 divided by 2? Which is 0. Z 0. Z corresponding to alpha is equal to 0. This area is 0. This area is 0 in the sense that onto the left of that point, there is no area. Z distribution goes from minus infinity plus infinity. So that this point value is how much? Minus infinity. So that y bar plus or minus infinity. Oops. Right. So that plus or minus infinity times sigma divided by square root of n. Infinity times infinity, sorry, sigma times infinity is infinity. So y bar plus or minus infinity. Y bar plus or minus infinity means that think maybe I need to get back to this screen. Right. So it is minus infinity to plus infinity. So that how do you make that statement interpretation? I am 100% confidence that the true mean is between minus infinity plus infinity. Yeah. No chance of making an error. But is it useful? No, this is not useful at all. This is like you don't know the mean, isn't it? What is the point of telling a value is between minus infinity plus infinity? It is another way of telling that you don't know the value, isn't it? Because any value on this earth is between minus infinity and plus infinity. Cannot have values outside minus infinity and plus infinity, isn't it? No use. No use at all. What we are aiming at is one value. When you say population mean, meaning just one value. We are trying to answer that question. But we know we cannot give one value. That's why approach used is that we give an interval. We construct an interval. Since what we are aiming at is a value, what we want is this interval to be as narrow as possible. Is it? As narrow as possible. Okay. So that recording it. No point having 100% confidence interval because the limits will be minus infinity plus infinity. So that we can understand when the confidence level increases, the interval is getting wider and wider. Thing is that usefulness get reduces. What we want is interval to be as narrow as possible. So that now if you think of 50% confidence interval and then 95% confidence interval. 50% confidence interval will be like this, something like 45 to 50, and then 95 confidence interval will be like 40 to 85. Now the question is that which one is more useful? This is first one is narrow. First one is narrow. Narrower. And then second one is wider. What we are looking for is a narrow interval. So in terms of width of the interval, first one is better. But on the other hand, amount of confidence is very low there. It's only 50%. So there's a 50% chance that our conclusion is wrong. We don't need that either. Isn't it? What we want is interval to be as narrow as possible while having fairly high level of confidence. Okay. So no point having 50% confidence interval just because the interval is narrow. Okay. And then is no point having very high level confidence, very high level confidence when the interval is very, very wide. We don't need that either. Okay. So that it is usually accepted, we go for just a minute. I think so conventionally we go for 95% confidence interval, and then definitely not less than 80% interval. Okay, we don't go less than 80% interval. Okay, so this is how we answered the question, how much is the value? Got it? Because it's a valid question. And then you can see by performing the test that we discussed, we cannot answer that question. Okay. Of course, if we do not reject the null hypothesis, we have an answer to the question. But when we reject the null hypothesis, we don't have answered that question. Using confidence interval also, in fact, we can do hypothesis testing. We can do hypothesis testing. Now, when you say confidence interval, 95% confidence interval, 40 to 80, what does this mean? We are 95% certain mean is between 40 to 80. Mean values between 40 to 80 are possible as the true mean. Values between 40 to 80 are possible as a true mean. Okay. So then, if null hypothesis is mu is equal to 60 and HA mu is not equal to 60, can we reject the null hypothesis? No, we cannot. Why? 60 is coming in between 40 to 80. Is that clear? Because according to the confidence interval, all those values are possible. Of course, 95% confidence is there, but that is the conclusion we have made. Meaning, there's a high chance that the true mean is 60. Because it's a value between 40 to 80. So that can we reject the null hypothesis? No, we cannot reject the null hypothesis. Is that clear? Right. How about 30? No, 30 we find outside the interval. So according to the confidence interval, it is not a possible value. So that we reject the null hypothesis. So that we can see, we can do hypothesis testing using confidence interval, and then all what we have to do is to check whether the null hypothetical value falls within the confidence interval or not. Whether the null hypothetical value falls within the confidence interval or not. That's all. If the null hypothetical value falls within the interval, we do not reject the null hypothesis, and if it does not fall within the interval, we reject the null hypothesis. Okay. The advantage of this approach is that, now you see, suppose, well, in the previous approach, is there a question or no? In the previous approach, remember we calculate the set statistic y bar minus null hypothetical value, or otherwise mu naught, and then sigma divided by square root of n. Right. Suppose mu naught is A. With mu naught A, let's say we rejected H naught. Now, mu naught is B. Do we reject the null hypothesis or not? Well, again, we need to perform the test with B. We need to calculate the test statistic and then compare that with the critical value that we obtain from the table. Okay. Meaning, for each hypothetical value, for each null hypothetical value exactance, we need to perform this test separately. Isn't it? But the advantage with the confidence interval approach is that we need to construct the interval only once. We need to construct the interval only once. And then any null hypothesis or any hypothesis can get tested. Any hypothesis can get tested. We don't need to construct the interval for each null hypothetical value. So see the advantage. What is the reason behind this? Because in the first approach, Z value depends on null hypothetical value. But the confidence interval y bar plus or minus Z alpha over 2 sigma divided by square root of n. Now see, H naught is not included. H naught is not there in the formula. Not in the formula. Because of that, confidence interval is independent from H naught. Because of that, we don't need to construct the confidence interval for each null hypothetical value separately. Whereas in the other approach, okay, using the test statistic approach, okay, you see, test statistic depends on the null hypothetical value, and thereby for each null hypothetical value, we need to calculate the test statistic separately. Okay, so that advantage is there with confidence interval approach. Okay. Consider case of studying a hypertense group. Hypertense. Hypertense. Suppose we are interested in systolic blood pressure. Systolic blood pressure. Right. What is H naught? We know if a person is normal, value is 120. Isn't it? Value is 120. Person is normal. But what we are studying is a hypertense group. Remember, null hypothesis is always a reference value. Isn't it? Starting point or reference value. So that this case, we will have it like what? H naught, VBC equal 120. And then HA, if you write it like maybe is not equal to 120, meaning what? It could be less than 120 or otherwise maybe is greater than 120. But we are talking about hypertense group. Hypertense group. Okay. So then, if it is different from 120, what values are possible? Then it has to be greater than 120, because we are talking about hypertense, high blood pressure. If it is high blood pressure, can we have the value to be less than 120? No, value cannot be 120. Isn't it? Because of that, in this kind of a situation, we can formulate the alternative hypothesis as what? Mu is greater than 120. Because less than 120 is not possible. Less than 120 is not possible. So that we can formulate it of the form mu is greater than 120. What does this mean? Null distribution 120. Earlier, what we did was we identified cutoff points then from this side as well as from this side. CL, CR, isn't it? And then we investigated whether the calculated value falls within the critical region or otherwise is the critical region or otherwise outside the critical region. Outside the critical region mean within this area or otherwise within this area. That is what we checked there. And if you can remember, said that this is what? Half of alpha, isn't it? This is other half of alpha. So alpha divided by 2 is what? Probability of committing type 1 error. Probability of committing type 1 error. So that there is alpha divided by 2 probability of committing the error from right hand side. From right hand side. And then there is probability of alpha divided by 2 to commit the error from left hand side. Isn't it? Right. But now what we are talking about is if mu is not equal to 120, mu is greater than 120. Mu is greater than 120 means values are possible only from this side. Values are possible only from this side. So that you can see this error is possible only from right hand side. Isn't it? Error is specifically type 1 error is not possible from left hand side. Error is not possible from the left hand side. So error is possible only from the right hand side. So if error is possible only from the right hand side, consequence of this is we have the whole alpha on one side. We have the whole alpha on one side. Because alpha is decided at the beginning. Now when the H naught is unidirectional. H naught is unidirectional. Early it was what? Early it was bidirectional. If it is unidirectional, then you find error is possible only from one side. In this case, only from the right hand side. So that you find the whole alpha on right hand side. Now, what is the consequence of that? Now, recall all together. This is mu naught. This is mu A, alternate distribution. And remember, something said is that alpha divided by 2, alpha divided by 2. Okay, right. This is under normal circumstances. But if we have the whole alpha on one side, okay, especially on right hand side, where do we have the new critical value? This is this is CR, this is CL, isn't it? This is what we usually have. Okay, right. Now we have the whole alpha. If we want to accommodate the whole alpha on right hand side, where do we have to shift this vertical line? Now you see area under the blue curve in this area is alpha divided by 2. Now we want this area to be alpha. Obviously, we have to shift this vertical line towards left. Somewhere there. So that now we have the area to be whole area to be alpha. Now where do we have the new critical value? CR, new critical value CR asterisk. We have here. We have there. Now, mu notice here, mu notice in the middle. Now the question is that CR, what is the relationship between CR and, CR asterisk and then CR? Which value is smaller? CR is closer to mu naught, isn't it? From left to right, values are increasing. So that CR asterisk is less than CR. CR asterisk is less than CR. Meaning we have smaller critical value. Smaller critical value. When the whole alpha is on one side. Smaller critical value. Okay. Smaller critical value in the sense that what can you say about chance of rejecting null hypothesis? Critical value leads to higher chance of rejecting H naught. Higher chance of rejecting H naught. Higher chance of rejecting the null hypothesis. Chance of rejecting null hypothesis is usually termed as the equivalent to whole higher power of the test. Higher power of the test. Okay. Right. Now look at this. Earlier, area under the red curve was this much, isn't it? So what is this? This is beta. Isn't it? Beta. Okay. And then after shifting the critical value up to this point, now beta, new beta, is only this much. Isn't it? Only that much. What has happened to beta? Beta has decreased. What has happened to beta is that beta has decreased. Isn't this interesting? Now, earlier we were telling two errors occur completely opposite to each other. Thereby, when you are trying to reduce one, the other increases. But this time, what has happened is that beta has decreased while alpha is remaining exactly at the same level. While having the alpha exactly at the same level. Okay. So now the area under the non-rejecting area is non-rejecting area. Well, earlier we had the values to be Only up to this. Only up to this. Isn't it? So how much is this area? This area? Since the area under the red curve beyond CR is beta, so that this is 1 minus beta. Isn't it? This is 1 minus beta. Now with the shift of the critical value, what has happened? 1 minus beta has got extended up to this point. Meaning 1 minus beta has got increased. Okay. See, 1 minus beta has got increased. This is what is meant by higher power of the test. So power of the test is nothing but 1 minus beta. Power of the test is 1 minus beta. Okay. See the consequence? So that as far as possible, by the way, what do you prefer? High power or less power? Of course, we are aiming at this also to reject the null hypothesis. Sometimes we fail to reject the null hypothesis. So that higher power is always preferred. See, higher power is always preferred. So that we can, as far as possible, then we should think of what? Unidirectional alternative hypothesis. Unidirectional alternative hypothesis. Unidirectional HA. In fact, the test that we perform with unidirectional alternative hypothesis is called one-tail test, or there is one-sided test. One-tail test. Now the whole alpha is only on one side, so that we call it one tail. Otherwise, the one that we discussed earlier is what? Two-tail test. When the alternative is bidirectional, the test that we perform is called two-tail test. Otherwise, if it is unidirectional, then the test is called one-tail test. So that you can see, one-tail test is always better. Then one might think of, can't we perform one-tail test then every time? No, we cannot. Why? Because if you want to perform one-tail test, in advance, you should know possible values for the alternative test. Now you see, hypertense. That if it is hypertense, then it is well established. We are talking about high blood pressure. And normal values are well established. But for certain situations, income of a group, you might not have information on whether it is greater than some value, or less than that value. You may not have that information. All what we are telling is that, alternative is that different. Okay. Maybe as an example, let's say imported variety. Thing is that we have no idea how that is possible in the place, where it was developed. It is a good variety. But the thing is that we have no idea how it will perform under our conditions. We have no idea. Okay. So it is possible that the yield is higher than the standard here, or otherwise less than the standard here. Exactly? We have no idea. So that the test that we had to perform is one-tail test. But like in the case of hypertension, although let's say one group has undergone training, another group has not undergone, or let's say a group has undergone training. So how do you expect that group compared to normal, or those who have not undergone that training? Yeah, what we expect is that those who have undergone training to be better, or their income to be higher. That is what is expected. I mean, after going through the training, their income will be higher. Suppose it is with respect to a profession. So then, giving a training, what is expected is that their income to be increased ultimately. So in such a case, we can think of test to be, after the training, can the income be decreased? No, income cannot be decreased because training is towards increasing the income. It's possible the training is not that effective, so that their income is still the same. That's possible. So what we are testing is same, income is same, reference is same. Otherwise, alternative is, if the income is different, then it has to be higher. Exactly. So this is how you decide whether the test is one-tail test or two-tail test.
Sir, excuse me, sir.
Yeah.
Yes,
go ahead.
Sir, in the graph,
Which graph?
The last one, under
This
the
one?
curve beta,
This one?
yes.
Okay.
And the curve beta, we minus from 1 beta only for the red color curve, the area under the red color curve. Can you explain? Can you explain a little bit more why it is we only deduct beta part here only?
Beta?
Yes, under the steric and CR steric and CR
Okay. Let me explain that again, so that you will understand.
Yeah, thank you, sir.
Critical value, well, under normal circumstances, the critical value is CR. Okay. Under normal circumstances, critical value is CR. CR from right-hand side and CL from the left-hand side. Okay. So that, you see, beta starts from this place towards left. Isn't it? This is beta. Now, if we want to have the whole alpha on one side, this critical value, this is CR, has to be shifted towards left. So the new critical value will be at this point. At this point, new critical value. Earlier, critical value is at this point, so that beta started from this point towards left, under the red curve. So that the area under the red curve, outside beta, which is 1 minus beta, is starting from this point towards right. By shifting it to new cutoff point, beta gets decreased, and thereby 1 minus beta starts from this point. So compared to earlier value, 1 minus beta has increased. Because area under the curve, total area under the curve is fixed, is 1, isn't it? Now by shifting, what has happened is that beta has got decreased, and thereby 1 minus beta has got increase. So that is what I explained. Alpha remains exactly the same, but beta has got reduced, and thereby 1 minus beta has got increased. Is that good enough?
Yes, sir. It's okay.
Okay, right.
Thank you very much, sir.
Right. So we're talking about one-tailed tests and two-tailed tests. I think homework. I think earlier I gave homework. So this time probably homework 1. Y bar is 150. Sigma is 100. N 20. Construct 95% confidence interval and interpret the results. Same question. Part 2. Using the confidence interval, test H0 V is equal 170 versus HA maybe is not equal to 170. Second one, Y bar 180, sigma 120, N is 25. Test H0 mu is equal to 190 versus HA mu is less than mu is 190 versus less than 190. Right. So attend to the homework. Examination or the real world, you should think of converting the real world situation into this form. Converting into this form. Now here I have not given any story, but any story you should be able to convert it into this situation. Okay, and formulate it into this form, and then you can perform the test. Now you see, this one is one-tailed test. See? Okay, right. Right. Third one. Y bar maybe 200. Sigma is 160. N is 20. By the way, here alpha is 0.05. Part 1 test. H node is equal 180 versus HA maybe is not equal to 100. If HA is maybe is equal to 250 is equal to how much? 150, maybe 230. HA is 230. Compute compute beta and power of the test. Compute beta and power of the test. Especially third one. Let's see. Here we have note. You know. So that first find see now the upper limit. Upper limit. Now alpha is given. Alpha is given. So given the alpha, you can find this value. CR. So once you find CR, you evaluate CR value with respect to mu A. Now mu A is given. So that you can find the second Z value. First you found critical Z critical value, that is CR. ZCR you found, and using ZCR you can find the Z2 for the red curve. Once you have the Z2, then from the table you can find this area. That area is theta. And then when you have that area, then you can calculate this area, which is 1 minus b. Okay. Right. So have a go. So that's about That's about homework. And then before that, we were talking about one-tail test and two-tail test. And then out of the two, which one is better? And then the reasons behind, well, how one-tail test is better than the two-tail test. Thing is that one-tail test cannot be performed every time. And then we discuss what requirements are there in order to perform one-tail test. What is the requirement? Information. Isn't it? Information. If you have information to say that it is greater than some value or less than some value, then we can always go for one-tail test. But if no such information is there, we have no choice other than two-tail test. So this is where we always say that you need to do good literature survey before you start undertaking in study. If you go through literature survey, you might find information is available, although you didn't know. But after going to the literature, you might come to know that values possible are greater than some value or less than some value. So if that is the case, you can go for one-tail test. Advantage of one-tail test is that the higher chance of rejecting null hypothesis. You will find new information. What you thought is, so what is established, what is accepted in the population is wrong. So that you can find the new information. So could be very, very useful. So it's very important that we generate that new information. Okay. So we need to use more powerful tests. And then see, earlier talking about confidence interval approach also. So one-tail test is more useful because there's higher chance of generating new information. And then one more thing about the confidence interval also, you see confidence interval is given by, see, we know the technology problem. Y bar plus or minus Z alpha over 2 sigma divided by square root of n. Isn't it? This is how we have. So the width of the interval is decided by this, isn't it? Width of the interval plus or minus some value gives the lower limit and then the upper limit. Width of the interval. If this part is large, width is large. If this part is small, width is small. So what we want is width to be as small as possible without losing the confidence. Without losing the confidence. Can we achieve that? Yes, we can achieve that. How can we achieve that? You see, n is something we can decide. N is something we can decide. When n is large, this whole thing is going to be, since Z alpha over 2, sorry, Z alpha over 2. Z alpha divided by 2 is a constant. Isn't it? It's a constant. And sigma is also constant. So by increasing n, Z alpha over 2 times sigma divided by n will be decreased. If this will be increasing and that narrower interval. You see, same alpha. Sorry, same level of confidence. Same level of confidence. So, by increasing n, having a larger sample, we can have more precise estimates. You see, standard error. This is what is called standard error, isn't it? Standard error is going to be smaller, and thereby width of the interval will also be decreased. Right, okay. That's how we have. Recall what we have done so far. Remember, testing hypothesis, we discussed Z test. Calculating it of the form y bar minus mu naught divided by sigma divided by square root of n. So you need to calculate Z. So in order to calculate Z, what do we need to know? Y bar. Do we know y bar? Of course we know. When we have a sample, we can calculate sample mean. And mu naught. Do we know mu naught? Of course, without a hypothesis, can we perform a test? No. So that mu naught is known. Sigma. Do we know sigma? So far, every time I gave sigma. Isn't it? I gave sigma. Okay. Where do we get sigma from? Literature. Sigma you need to get from the literature. N. N is of course known. When you have a sample, you know how many observations are there in sample. So that you can see. In order to perform this test, Z test, you need to know sigma. You need to know sigma. Sigma can be found from the literature, but the thing is that if you are talking about new concept where people haven't done that much of research in that area, then the thing is that you have no information about sigma. So then the question is that sigma is not known. How do you perform the test? One possibility is that use large n. Use large n. If you use large n, in the sense that what? Large n, then the sample standard deviation S sample standard deviation S can be used in the place of sigma, and thereby perform the test. Naturally, when n increases, meaning sample is getting closer and closer to the population. Okay. Sample is getting closer and closer to the population. So that, well, it's fair enough. Sample standard deviation is used in the place of sigma. No problem. But the thing is, if n is small, then we find if n is small, so we are telling is if n is small, y bar minus mu naught, sorry, y bar minus mu, we're talking about true values, divided by S divided by square root of n does not follow the Z distribution. This is the problem. Does not follow the Z distribution. But if S is from large sample, then if S is from large sample, it follows the Z distribution. Y bar minus mu S divided by square root of n follows the Z distribution. When n is large. But if n is small, you find that this quantity y bar minus mu S divided by square root of n does not follow the Z distribution. In fact, In fact, 1908, Gossett found with small samples, when n is small, y bar minus mu S divided by square root of n to follow a distribution slightly wider than standard normal distribution. Center is same. Center is same. So the new distribution, this blue one, is follow the distribution with slightly wider tail. Tail region is larger. So that now if you think of a specific critical value, now you see red area is only this much, but the blue area is larger. Exactly, the blue area is larger. This distribution, this is what that person found. With small sample, we find this quantity to be distributed with slightly wider tail compared to Z distribution. And this distribution is called T distribution. T distribution. Now, interestingly, when n is getting larger and larger, now earlier what we said is when n is large, this quantity has what distribution? Z distribution. When n is large, this quantity is having Z distribution. Meaning this blue distribution reaches to Z distribution when n increases. Okay. Z is what? Limit of T when N reaches to infinity. So T, now we can see when it comes to T distribution, now you can see that not that one distribution we can think of it. Oh, just now what I said is that when N increases, it reaches to what? Is a distribution. When N is very large, you find T distribution overlapping with is a distribution. So that when N increases, orders with different N, we find what? Different T distributions. We find T distribution with, well, T distribution to vary depending on, because earlier what we said is that if N is large, that quantity is having Z distribution. And after that, what we said is, if N is small, that quantity does not have Z distribution. And the distribution is slightly wider compared to Z distribution. So that when N increases, what is happening is T distribution is getting closer and closer to Z distribution. Okay. So that if N is small, the distribution is now different from Z. Because of that, we need to have new critical values. So the new critical values have to be obtained from T distribution. And as the way we said that T distribution vary depending on sample size, not just one distribution. T distribution vary depending on sample size. In fact, in exact terms, T distribution vary depending on degrees of freedom. What is degrees of freedom? That is N minus 1. So T distribution properties symmetric around 0. Mean is equal to 0. Variance slightly larger than 1. Now, standard normal variance is equal to 1, isn't it? He said slightly larger than 1. Variance gets slightly larger than 1. Okay. Important is that single parameter distribution. It's a single parameter distribution, and the parameter is N degrees of freedom, which is N minus 1. And then wider tail area, wider tails compared to Z. Right. I think with that, let's have the quiz pretty quickly, huh? Can everybody get ready? The quiz. Can everybody get ready quickly? Ranatunga, RMTK Ranatunga.
Yes, sir. I think it's a problem related with my camera. I'm trying my best to fix that, sir.
No, thing is, I have said several times that you need to get those things, organized and then check, but before joining the meeting. Last week also, remember one or two said that, it's not working and blah, blah, blah. I said that, well, make sure that, your the device is working. Vinuti, are you ready? Or not? Is there a person called Vinuti? No? Helena? Helena Abeyakon? No? Sujeeva Karunaratne?
Okay, sir.
Yeah. Have the camera on. Upendra? Upendra? Missing? Upendra is okay, around. Duminder, not ready yet? I think Upendra is missing again. Right. Let me have a simple one. Finish it quickly, okay? This with N1, this is with N2. N1, red one is with N1, blue one is with N2. Okay. And both are T distributions. Both are T distributions. Question is, now remember, need to have cutoff point, isn't it? Critical value. Need to have critical values. See, now the question is that which critical value in terms of absolute value, okay? Is larger. Which critical value is larger? Critical value is corresponding to fixed alpha. Say fixed alpha 0.05 or something, fixed alpha. And which critical value is large. So you can tell whether it is with N1 or otherwise N2. Then in one or two words, give a justification for your answer. Don't write stories. Which critical value is large? Alpha is nothing but the tail area, isn't it? Alpha is nothing but the tail area. So now look at the two curves, think about the area, and then you can identify that, then you can judge which critical value is larger and which critical value is smaller. AMPD, Abekon, are you around? So why are you hiding? Still can't see you on the screen. Can you shift the screen bit more, bit more? You can turn the screen bit. Assis, Assis, what is happening?
Yes, sir.
I can't see you on the screen. I think Upendra is missing, isn't it? Duminda Bandara, are you around or missing? Until I save the answers, everybody has to have the cameras on. I think now it's more than 10 minutes. So can everybody send it quickly? Has everybody finished sending? Right. Looks like everybody has sent. Can I close it now? Right. Don't send it after I close it. I will not assess them. Can I close it now? Since nobody's talking, looks like everybody has finished sending. Is that okay? Yeah. So let me save it. Don't send any more. I said don't send any more. Right, which critical value in terms of absolute value is larger? See, critical values we can have from both sides. And you can see properties, symmetric around 0, variance is slightly larger, isn't it? Variance slightly larger means tail areas are larger. So that right in the middle, we have what value? 0. Isn't it? 0. So now critical value you see under blue curve only this much. Under red curve we have this much. under red curve area is higher. So if red curve area is 0.05, if under red curve area 0.05, the area under the blue curve is less than 0.05. Isn't it? So in order to increase the area, critical value for the blue curve, so in order to accommodate larger area, the critical value, sorry, this vertical line have to be shifted towards the center, isn't it? Center to accommodate higher area. Blue area has to be under blue curve, it has to be higher. So that this is C asterisk, let's say. Now C asterisk is closer to 0. Closer to 0, isn't it? So that in terms of absolute value, then C asterisk is closer to 0, and that smaller than C. C asterisk is smaller than C. So that which critical value is larger? Is C critical value, that is with N1 critical value is larger than N2 critical value. N1 is having higher value compared to N2. N2 is the inner one. Because N1 curve is having larger tail area. N1 is having larger tail area, then definitely it has to be what? Smaller sample size. So it has to be a smaller sample size. When sample size is getting larger and larger, it is getting closer and closer to the Z curve. So that the area under N1 is larger in sense that critical value is larger. Okay, that's the answer to the question. And regarding next week meeting, I suppose everybody knows by now, since everybody has got the schedule at the beginning, we don't have a meeting in the next week. So that we will be meeting again in 2 weeks' time. Okay. Coming week, Saturday and Sunday, we have no meetings. But tomorrow, of course, we will be meeting. And then one more thing is that regarding the examination, final examination, I think one person asked this question some other time. Well, principle is that exam is open book. Theoretically, exam is open book, meaning you can have your notes, textbooks, everything with you. And then the thing is that examination will be not online unless the person is in overseas. If a person is taking part in the course from overseas, that person can attend to the examination also online. But others have to be physically present at the PGIA. Okay. So those who want to sit for the examination from overseas or the online, you should provide the evidence saying that you are not in the country, so that we can make an arrangement. You need to inform us in advance. Others have to be physically present at the PGIA. That is for the examination. And then the examination is open book. Okay. But it's better open book in sense that without taking the whole note set with you, the whole note set with you, you can have, let's say, 2, 3, maybe 2, depending on if you find it to be enough, 2 A4 sheets with you, anything written on that A4 sheets. The reason is this: when the whole note set is allowed, then the thing is that everybody starts studying during the examination. Examination is not the time to study, isn't it? You have to study and come for the examination. But we find that when we announce that the examination is open book, students don't study and come. They think that, okay, well, they can answer the question by going through the notes, and then they start studying during the examination. So by the time you find the answer, the time is over. Best thing is, whatever you want, you get them transferred into 2 A4 sheets. Is that enough? 2 A4 sheets and then 4 sides. Yeah, maybe you can let me know. Okay, maybe 2, maybe 3. Likewise, we'll decide. But that's all as material allowed, but not the whole note set. Okay. So that it is guaranteed you have at least you have gone through the notes at least once. Otherwise, without going through the note at least once, students come to the examination. Okay, so that is usually the arrangement. Okay, right. That's all from me for today. Any questions? Now, somebody was asking something, and I said I usually entertain such questions after the meeting. Yeah, this is the time. Somebody wanted to say something? That this is pass mark. Interesting. Thing is that grading, you need to have the grade C or above. Okay. At the PGIA, in order to pass a course, you need to have grade minimum of C. And then the cutoff point is distribution based. There is no fixed cutoff point. We look at the distribution and decide. Okay, it's a distribution based grading is the procedure adopted. We look at the distribution because we find it to be like it's better. Otherwise, if we fix it like, let's say, 50 marks or 60 marks, that's the cutoff point for C grade, then we see that a lot of students cannot pass. So we find it to be, the principle is that we look at the distribution and decide. Okay, doesn't mean that if all the marks are low, person with 30 marks will also pass. No, it won't happen it that way. Okay. And just because person is having the highest mark doesn't mean that that person will end up with an A. Suppose the highest mark is 50, that person will not end up with an A. Remember that. No fixed cutoff point. So we just look at how students have performed, and accordingly we decide the cutoff point for different grades. The advantage is that, say, for instance, well, otherwise usually cutoff point is 85 and above only A. 80 to 85, A minus. 75 to 80, probably B plus and likewise. But sometimes we find the highest mark is 79. So that not a single A for the whole course. Because of that, what we do is we just look at the distribution and then decide the grades. Thereby, students will be better off. But it does not mean, why I said this earlier also, does not mean that just because you have got the highest mark, you will end up with an A. You need to have substantially high mark in order to get an A. And then similarly, in case, if you happen to have very low marks for most of the students, doesn't mean that your pass mark will also be substantially low. Okay, so keep those things in mind. Although students are better off, doesn't mean that, without studying or without answering properly, you can pass the exam. Don't take it in that way. So that's a bit about examination. So get prepared then. So you need to be present here physically. And the other thing is, you need to study and come. Don't think of studying during the examination. Okay, anything else? No, this is not counted for GPA, but you need to have at least C grade, otherwise you cannot graduate. Thing is that this grade is going to go to the transcript. Although it is not counted for the transcript, counted for the GPA, the grade will appear in the transcript. See, everybody will decide your performance by looking at the transcript. Of course, the GPA is there, transcript. So it's good to have an A in the transcript. You can easily have an A for this course. So if you can understand what I say, you can easily get an A. Okay, but somehow this is not counted for GPA. Past papers, you can find from students of the previous course, but sample papers are kept in the PGIA library. Maybe I will share a model paper with you the latter part of the course. Maybe in the after next meeting, sample paper. But past papers, and a copy of the past papers you find in the library. So if you happen to come to the library, you can have that. But otherwise, I will share a model paper. Okay. Is that all? Anything else? Right. If that is the case, that's all for the day. So we'll meet tomorrow morning at 8 o'clock. Okay. Right. Can I close it now? Okay.
Thank you, sir.
Okay, you're welcome.
Thank you.
Thank
Yeah.
you.
Sir, good night.
Thank you, sir.
Yeah.
Thank you, sir.
Okay, you're welcome.